Okay, guys, this video is going to be over the lab of precipitates of ionic compounds. We covered chapter 4, so I want to do a lab where you can see precipitation reactions and predict the products of them. So let's see. Lab precipitates of ionic compounds. And what we're going to be doing is essentially this right here. Okay. So we're going to record our observations in the squares below for each solution. So we're going to take a solution of silver nitrate, which is 1. And so I've got it here. It's not a clear solution, and that's because it's kind of strong. And silver nitrate usually has a little bit of a color to it, kind of this grayish color. I did mix the silver nitrate in tap water, and so it's probably reacting with some chlorine or some hydroxide in that water, or it's reacting with something in the water because it's got contaminants because it's tap water. I should have made these in distilled water or pure water, but I had tap water, so that's what I ended up using. So here is our solution. This is silver nitrate. Let's see. You guys cannot see what I'm writing. Here we go. Okay, so we have silver nitrate and sodium carbonate. And so those are the two things that we're going to be mixing together for number 1. I got to make sure that you guys can see what I'm doing. Okay, awesome. Okay, so let's write the reaction. AgNO3 plus Na2CO3. This is a double displacement reaction, and so they are going to change places. So silver is dancing with the nitrate here, and sodium is dancing with the carbonate. And what they're going to do is they're going to change partners. Silver will go with the carbonate to form silver carbonate. And then the formula is going to be so that I balance the charge. Silver is a +1. Carbonate is a -2. And so I need 2 silvers to balance that charge. And carbonates are insoluble, so this will form a solid. And so when we mix the two together, we'll see that solid. And then we're going to have sodium go with the nitrate. So these two guys are going to pair up, and that's going to be Na. Sodium is a +1 charge. It's a group 1 metal. And so that will be Na. What's the plus sign there for? Na2. Wait, NaNO3. Nitrate's a -1, and so we just need 1 of each. And that will be aqueous because all group 1 metals are soluble, and they make aqueous solutions with water, and so do nitrates, with no exceptions. Anything that has a group 1 metal will be soluble. Anything that has a nitrate will be soluble. So let's go ahead and mix these two, and we're predicting a solid. We're going to predict Ag2CO3. I think that's going to be a white solid. So let's go ahead and add the sodium carbonate in here and see what we get. Sodium carbonate. Here we go. Let's see what we get. So if I add a little bit, you can see it's getting cloudy. Right? Just find the best angle for this. Let's add a whole bunch in there. Notice that it's completely cloudy now. Okay. And I can mix it a little bit. So now it's cloudy. It's not that pretty of a liquid, kind of meh. So we formed silver carbonate, Ag2CO3. That's what we got there. So I want you guys to write the ionic equation for that, the net ionic equation, the total ionic equation, all those things, and practice that. I did this lab before, and I had a lot of technical issues. I had the chipmunk show up. So the mysterious chipmunk that I get out of my camera every once in a while, he showed up and ruined my video. And then also all the writing that I did on the video, like I'm writing on the thing right now, all of the writing was not there either. So it was like a total mess up of a video. So I'm just redoing the whole thing. But the point is I made all of the solutions in that video, And I have them sitting over here. And so if you, I don't know if you can see them, they're sitting on that table over there. There's 12 of them. All right, you'll see that? And so what I'm going to do now is I'm going to grab this one, and I'm going to pour off the liquid, and we'll see if we see a solid that is left over from yesterday. Okay, and I don't know if you guys will be able to see this, but there is some kind of stuff in there. Still wet though. Let me see if I can get rid of the water. See, ideally we want to filter this. Let me go see if I can find a filter, and I'll be right back because I like to do a filter that. Okay, I got my filter, and this will be an example of filtration. So I've got my solution here. I'm going to try to get this out. I'm just going to take a big Erlenmeyer flask, which is this thing, and I'm going to put my filter on top. You can see that, and I got some filter paper. This is some coffee paper in here, and so I'm going to pour off this guy into here and let it filter through. The water should go through the paper. The solid will not. Okay, so we can separate a mixture by doing this. Now I'm making some water so that I can spray it a little bit. I'm just getting some tap water for this. Let's see. So the liquid will go through, the solid will remain. This is kind of thick filter paper. Why is the liquid not going through? Maybe it needs to sit. That's water, so I don't want to mix that up with anything else. Come on, Mr. Water, go through the filter paper. Maybe this filter paper is too thick. It'll probably just take time, so that'll evaporate. But if we look here at our filter paper, I don't know if I can get a shot of this without making a mess. I will try though. Let's see, put my filter, my paper beaker there. So if you can look at this, you can see this kind of brown, liquidy, solid stuff. Okay, and that's our precipitate. Okay, I'm trying to filter it, and I'll show you guys the filter a little later. So I'm going to leave this one like that and let it sit there. So this is number one. Actually, I can totally leave that there. That's totally fine. All right, let's do number two. All right, so I got my beaker number two. This will be lead 2 nitrate. All right, remember when I say lead 2 nitrate, I am saying that the 2, that 2 represents a charge on lead. So it's a lead with a +2 charge. And then I have 2 nitrates. So PbNO3, 2. And the reason I need 2 nitrates is because the lead is a +2. So I got to balance that charge. Okay, so Pb +2 nitrates. Let's just practice our formulas. So I'm going to mix that with sodium carbonate. So right now I have, this is actually precipitating out already. Notice it's a little cloudy already, and that's because of the lead. The lead's probably reacting with chlorine in the water to make lead chloride. So that's that white solid. But I've got lead nitrate here. I'm going to mix it with sodium carbonate and see if we can get a solid to form. We're going to expect to see, where'd my pen go? We're going to expect to see lead carbonate, PbCO3, as a solid, and we're going to get sodium nitrate, which is going to be aqueous. So that's going to be the products of this reaction. So let's see what we get. Mr. Sodium Carbonate, will you come out to play? Ooh, there we go. We get that white solid. This is why I wanted to show you guys these, is because they're kind of fun. And so we get this nice milky white solid. And most of the solids that we see in this lab will be white. Okay, so this is lead carbonate, lead 2 carbonate, PbCO3. Now let's do the same thing. Let's take my flask here. Some more filter paper. And we're going to try to filter this one as well. Here's my filter paper. Here's another filter. Ta-da-da-da. Okay, I'm going to pour this guy into my filter paper. Hopefully I keep it in there. The filter paper is almost too big for this filter, but it'll work. Whoa. Well, this time it's going through. Is there a hole in this filter paper? Because it's not staying in the filter. That didn't work so well. Maybe we'll get some solid at the top. Huh. All right, number 2. All right, so this is the number 2 from last time. Okay, and so I'm going to pour this in the filter paper. This one's been sitting all night, and so I should get some of that solid at the bottom. So you can see this white solid. It's still kind of wet, so it still looks wet, but it's a solid. It's just mixed with the liquid, so that's why it looks wet a little bit. Okay, what do we got going on here? I'm gonna let this filter for a little while again, and then we'll come back to that and look at that. That's number 2. Okay, I'm making a mess. All right, number 3. Number 3 will be calcium chloride and sodium carbonate. And so we're going to form calcium carbonate, which will be a solid, and sodium chloride, which will be aqueous. Chlorides are usually aqueous, especially when they're with a group 1 metal. All group 1 metals are soluble, and they will be aqueous in solution. And so we're going to get sodium and chlorine ions swimming in solution, but we're going to get a solid calcium carbonate. And I want to mention something else that's in calcium carbonate. One of my favorite things to eat, Tums, calcium carbonate. If y'all can see it right there, calcium carbonate. So that's the prime ingredient, active ingredient in Tums that is used to fight acid. So let's try taking some calcium chloride, which is here, and we're going to mix sodium carbonate with it. Here's our sodium carbonate. Let's try to look for it. Notice that we're getting a solid already, kind of. Okay, so that's what we get. Okay, let's try to filter it again. I'm just going to use this same flask. Here's my only remaining filter. Maybe I should cut this filter paper. That's what I'm going to do. I feel like I'm wasting it. I'm going to cut it into 4ths. There we go. And then we can kind of just put this in here. like that and filter it. Oh, maybe I made it too small. That'll work. Okay, and so now I'm going to pour that in there. Let's see if I can filter out our solid. And then I'm going to do the same thing. I'm going to take the solution that I made yesterday and put it in there. This one you can actually see the solid as well in the bottom of our beaker here. Hard to see. And actually, if I get this one wet, oh, I don't want to use that. I want to use water. So if we put some water in here, you can see that the solid will clear up. Why is this not giving me any water? It's got to be closed if you want it to work. Okay. So here's our water. Notice that it's clean on the bottom now. Right, and so I got all that solid in the water. And so if I mix it around a little bit, pour it into our funnel, we should get some solid. And that's awfully milky. Okay. And then I'm going to let this sit in here. Okay. Number 4. Number 4 is going to be silver nitrate, which I have right here. Notice kind of the dark color. And sodium phosphate. So let's add some sodium phosphate to this. I'm not seeing anything. We would expect to see silver phosphate, but silver phosphate is aqueous. But I think I don't see anything. Excuse me. Let's look at number 4 from yesterday. And here I'm seeing something. So I think it just takes some time. So maybe I can't filter this one because I don't have any more filters, but this one we do see a solid, but not that well. So this is what we would get. And this one's a weird color. Maybe because the silver nitrate sat overnight, maybe because it's mixing with something in the water. But that's what we would get. Maybe something will precipitate out of that if I let it sit for a while. That's number 4. Let's pour these together so I can make them all solid. And I'll let that water evaporate and see if we can get something to precipitate. But what we would expect to see would be Ag3PO4. Which I think would be solid. So we should see a solid in there. All right, number 5. Number 5 is going to be lead nitrate and sodium phosphate. So lead nitrate is already in here. It's already kind of a whitish color. We're going to add some sodium phosphate to it. Woo! And we get milk. Yum, yum. Anybody want to drink? So we are making lead phosphate, lead 2 phosphate. So let me get my pen, which would have the formula Pb3PO4 2. And so the lead is a +2, phosphate is a -3. All right, I'm going to show you guys the cross trick. You guys probably know this, but I want to go over it. The charge on the lead is +2, and it will come down to go right there. So it'll cross to its other partner. The charge on lead will tell me how many phosphates I need in the compound for it to be charge balanced. And then the -3 here will go down and tell me how many leads I need in the formula. So Pb3 phosphate 2. And so look at the charge here, Pb +2, and I got 3 of them. My net positive charge is a +6. And then I got 2 phosphates. Each is a -3. Guess what my net negative charge is? That's right, -6. Equal and opposite charge for ionic compounds. And so that's our solid here. It's very solid on the bottom. And let's look at the one from yesterday. Number 5. So I'm going to pour the liquid on top. So this is what we have. I'm going to pour the liquid on top. Trying to pour it slowly so that I don't disturb the solid. And as you can see, there's our solid. Yum, yum. And if I filtered that, then I would get, actually, maybe I could take one of the filter papers that's done, like this one. Maybe I can reuse the filter. Let's take a look. Because I want to filter this one, because this one looks cool. So let's take this guy. Let's take our waste beaker, which is now going to have all kinds of heavy metals in it. And so I'm going to have to send that off to be picked up. I can't pour that down the drain with the silver and the lead in there. Those are hazardous to our water supply. So they will go in a jug, and I will hold on to the jug as long as I need to until they come and pick it up. So let's get some water in here so that I can gather all of this solid that settled out. Num num. And let's see if we can filter it. And hopefully by the end of the video, we'll see some results. Let's actually get some more water in here. So I'm going to spray it, holding it like so, and make sure I try to get all that solid. Yummy, yummy. And let's do the same thing with this one. Try to get all that solid. Oh, and it's draining slow. Okay, well, I'm going to let that sit out. I'm going to have to move it over to 5, though, because I want to keep it labeled. Let's move it. There we go. I'm going to let it settle out there. Add some more. There we go. Now let's get some more water in here and get all this solid. All right. I'm going to let that settle out. Hopefully we'll get some solid. That's number 5. Okay, I'll get my papers ready again. All right, number 6. Number 6, we're going to take calcium chloride, which I have right here in this beaker, and we're going to mix it with sodium phosphate. All right. We will expect to get calcium phosphate. Notice that this is pretty clear. Okay, calcium chloride is very aqueous, very soluble, and so it's pretty clear liquid. One of the most clear solutions we've seen yet. Okay, now let's add some sodium phosphate to it. Notice here that nothing happens. I mean, look, there's nothing. It's still the same color, everything. No reaction. Okay, why is there no reaction? Calcium chloride plus sodium phosphate will form calcium phosphate, which is going to be Ca3PO42, and sodium chloride. So calcium phosphate is aqueous, although most phosphates are soluble or insoluble, but this one is soluble, and then sodium chloride is soluble. So they are all in solution. So why do we consider this to be no reaction? Let's take a look at that. Okay, I'm going to have to erase here. So calcium ions plus chloride ions plus sodium ions plus phosphate ions, all in solution, all aqueous. So I'm going to write AQ for that one, and it's the same for every one of them. They're going to react to form calcium phosphate aqueous and sodium chloride aqueous. Let's write this as a total ionic and see what we get. Come on, eraser. So we're going to get calcium ions, chloride ions. Actually, we're going to have calcium and phosphate. PO4 3 minus. We're going to have some calcium ions. We're going to have some chloride ions. And these, again, are aqueous in solution, all of them. So I'm not going to write it, but they're all aqueous in solution. So these are my reactants. The bottom is my products. I have the same thing on both sides, so they cancel out. Oh, did I write calcium twice? This should be sodium. So sodium will cancel with itself, phosphate. So everything cancels. No reaction. All aqueous before, all aqueous after, and so no reaction, no solid. And that's a double displacement reaction. They change places, but there's no reaction. So since no solid forms, we would say no reaction for that one. Awesome. That's number 6. I don't have much of number 6 left, but I'll show you what I do have. And there's nothing really exciting in here, but there is something at the bottom of the container. The water's gone, but I don't know what's in the bottom of the beaker there. So, but there's no solid. So that's number 6. Number 7 will be silver nitrate, which I have here. Notice the kind of grayish reddish color again. And sodium hydroxide, and this one's going to be cool. AgNO3, which is aqueous. We're going to add that to NaOH, which is also aqueous because all group 1 metals are soluble. We're going to end up with silver hydroxide, AgOH, it will be solid, and sodium nitrate, which is always aqueous. So it'll be a spectator ion. So let's get the hydroxide. Oh, I forgot to mention, I used KOH. So we're actually mixing KOH and AgNO3. And so what we are going to be ending up with is still silver hydroxide, but we're going to be making KNO3 instead. KNO3 instead, which doesn't matter. But I didn't have sodium hydroxide, so I used potassium hydroxide instead. So let's see what we get. Woo! It just turns muddy and a dark brown. Yum. That's nice. So we get this dark brown. And so that cloudiness is solid that is trying to form out of solution, but it's still wet. It's still mixed in there. And it's forming kind of microscopically, so it's kind of small. So that's why you don't just see a solid just appear. But if you were to filter that and then look at the solid, you'll let it dry, then you've got a solid. Sure. So this was number 7. So let's pour this one out. This is the bottle from yesterday. And so let's pour that here. Slowly, ever so slowly. I really want to filter this one, but I don't have a filter, but maybe we will. Look at the solid in there. Let's filter this one. For sure. Sorry, dude, you are going to be filtered. It's not optional. I'm going to throw this one away because I didn't do anything. Okay, here's a filter. Where's filter paper? Filter paper, there we go. And then I'm going to pour this on top. And it'll kind of mold to the funnel shape a little bit. Yum, yum. And y'all can't see that brown color in there. I wish I could get the shot in the filter. Maybe if I pick up my camera. Let's pick up my camera and see. So you can see the brown color in there. And I'm using the camera that I have on my desk because I need the iPad to write the notes, because I want you guys to be able to see this in real life and then connect it to the chemistry. Okay, so we got that going. Let's add some water here and get this nice and wet. Mix it a little bit and then pour it on. And we're going to check this one out later. Ooh. And I want to see that solid. Let it dry. And if I didn't want to wait, I could heat the solid and drive off the water. I could heat the water and get it all gone. But I don't want to. But we'll just wait. So that's not number two. What was that? Number 7. Okay, for the next ones, I'm just going to show you guys what we ended up with, just for time. So here's number 8. Number 8 was lead 2 nitrate and sodium hydroxide, actually potassium hydroxide. And so what we ended up making is PbOH2, which is a solid. And so that's that white solid in there, lead hydroxide. And then we also have sodium nitrate in solution. So that's what we got with this one. And as you guys can see, it's very solid in there. We got some stuff floating on top. Let's actually mix it and see if we get this nice milky color again. If I mix it. So I'm gonna let that settle out a little bit more. That's number 8. Number 9 is calcium chloride and sodium hydroxide, and we end up making calcium hydroxide, which is solid, and sodium. Actually, remember it was potassium. And so this was potassium chloride, KCl, which would be aqueous because it's got potassium, which is a group 1 metal. And so the solid is calcium hydroxide. Again, if we mix it, we can see that milky color. Okay, that's number 9. Number 10. This looks cool. What's going on in there? Number 10. Let's check this one out. Number 10 is silver nitrate and sodium sulfate. So we're going to make silver sulfate. And that's what that solid should be. And I kind of want to filter this one because this looks cool. Yep, I'm going to filter this one. Let's cut some more filter paper. This time I'm just going to cut it in half instead of thirds, or instead of fourths. That way I can get it in the filter. So we need our waste. Yum, yum. This one's pretty good, so let's see which one of these is done. This one's not really done now. Maybe if I just put it right there. And then keep those together. Remember that that's the same solution. So let's put our filter paper here. And let's filter number 10 and we'll check it out. Come on now. Work with me. All right. So let's shake this up. Pour it in our filter. Let's filter this beautiful solid. I want to see that. So that's number 10. And I'm going to let that filter. And hopefully y'all can see the kind of purplish brownish color in there. Cool. All right, I'm going to let that filter. I'm going to let that sit. So number 10. You're going to go back in your bottle that's labeled. All right, number 11. So let's move this. Here's number 11. We get a white solid at the bottom. See the liquid on top and the white on bottom? If we mix it, we get our milky color again. Yum, yum. All right, number 11 is lead 2 nitrate and sodium sulfate. And so we're forming lead sulfate, lead 2 sulfate, which is solid. And then we're going to have, I think again, I used potassium sulfate. I'm trying to remember which one I used. Yeah, I used potassium sulfate. So this is K2SO4. And so we're going to get lead sulfate and potassium nitrate, which is going to be aqueous because of the potassium. Group 1 metals are soluble. So that's number 11. Yum, yum. Nice white solid again. And I wish I had some examples that had some other colored solids, and I'll show you guys those later. And I remember showing you guys before when we started talking about solutions. But here's number 12. Number 12, our last one, will be calcium chloride and sodium sulfate. And we see a solid at the bottom. Actually quite nice solid, if you can see in there. Let's mix it up. This one's harder to mix because it's a different shaped bottle. Let's actually pour the water off and see if we can see the solid a little up closer. I need a funnel. Right? Maybe I don't need a funnel. Whoa, now we're getting some solids in there. Did y'all see that? So this is precipitating with other stuff, which is cool. It's always fun to just pour all the stuff together and see what nasty mess we can make. Now this is safe as long as you don't make any gases. If you make some gases, then you got problems because you'll be breathing those gases. But if it's all solid and it's in that container, I got my goggles on, so we're good. So here's a solid. Cool. Now let's mix this up and see what we get. Yum, yum. Let's pour some sodium sulfate in there. Let's put, I want to put some silver nitrate in there and see what we get. And now I'm just playing. Silver nitrate, where are you? See what we can get. Not much. I was expecting a little bit more of a reaction there. Let's see if I can mix something else in there. Let's put some lead in there. Lead always precipitates out. Let's see if we can get something cool happen here. There we go. So now we're making a white. Trying to think what else I got. Let me go see if I got anything else I can mix with this and make something cool. How about hydroxide? Hydroxides always precipitate out. Let's try that. Okay, now I'm getting full. So let's move some of this nice stuff to another beaker. And now I'm going to have 2 beakers with colorful stuff. Let me see what else I got back here. Something interesting. Okay, so this should be pretty cool. I'm going to add some iodine solution, gram iodine solution, to this one. And I think we're going to see a yellow solid. That's what I'm hoping, but I'm not sure. Let's see what we get. Let's hope I don't hear a boom. Okay, no boom, but definitely cool looking. Let's let that mix and settle out. We get coffee. Cool. All right, the other one I'm going to add litmus solution, which is pH sensitive. And so this one should produce some color. Let's see what we get. Okay. So let's mix this up. Oh, wow. Cool. And let's let it settle out and see what we get. I'm going to add some iodine to this one too. Maybe we get a different color. Okay, this one's all gone. Let's add some sodium carbonate to this one. Notice we get some color changes. Oh, very cool. That one changed the pH of it. Check this one out. Look at the bottom. I mean, it's just caked with solid. I can't see that, darn. What if I mix these two together? Boom. I hope there's no explosion. Okay, let's look at some of the solids. I'm going to let those settle out, and then you guys can kind of watch them and see what happens. Let's look at our solids. So here is number one. This is silver carbonate. Notice it's a nice solid on the filter paper. So it actually formed a solid in there. And if it dried completely, I could probably scrape it out and have solid, kind of like a powder, silver carbonate. So there's that one. Here's number two. Number two was lead carbonate. And so that is the solid that we get from it. Very nice. You can see that. Hope I don't get this on me. So that's a nice white solid there. The lighting in here is not too great. Let me see if I can turn off the lights. It's a little too bright. Maybe that's better. You can see better. Less light. Okay, let's see. Not really. It was better before, wasn't it? But now you can see that solid. Okay, let's check out some more solids. I just noticed it was had a reflection. Okay, so let's put this one back in this beaker without touching it, I hope. I've got another white one, which is not that interesting, and I've got some others, but they haven't really solidified. There's not much to see. So I think that's it, guys. Thank you. Do y'all see? These are kind of cool looking. I'll wait and see what happens with those. All right, guys. Have a good one. Thank you.